Neighbors in Washington County swarmed social media this morning after they felt their houses shaking. We told you at 5 that shaking was actually caused by an earthquake.
Scientists across the Pacific Northwest have raised the alarm in a region that has always lived with a quiet fear of earthquakes. But now, something never seen before seems to be happening. Washington's crust is changing in a way that has even experienced geologists paying close attention. This isn't some far-off prediction. It's happening right under our feet, from the wild Olympic Peninsula to the busy cities around Puget Sound. A hidden system of deep cracks appears to be forming beneath Washington. These cracks may stretch under the ocean, shifting the ground and forcing scientists to rethink what they know about this already active land. For the first time, seismic monitors are picking up movement beneath the Pacific Northwest subduction zone that suggests major changes are happening deep below, possibly cracking rock and shifting layers on a scale modern tools have never clearly recorded before. The possible impact of these discoveries is hard to even imagine. Recent tremors have shaken neighborhoods from Seattle to Bellingham, causing more emergency alerts and leaving residents reporting strange ground breaks that weren't there before. In remote parts of Washington, people have spotted fresh cracks slicing through land that once seemed solid and stable. Coastal towns, scientists, and locals all describe a landscape that feels like it changed overnight, an unsettling reminder that the earth beneath us is always moving. Fear is growing as seismic experts, including geophysicists leading major research teams across the Pacific Northwest, confirm the region is going through a type of crust adjustment that hasn't been documented with this much detail or speed before. New seismic data shows the subduction zone, where the oceanic Juan de Fuca plate pushes beneath North America, is not just shifting in a normal way. It may be going through deeper, more complicated changes far below the surface. Out on the seafloor off Oregon and Washington, seismic sensors have detected unusual activity. Scientists are now studying whether this includes the formation of deep cracks or fissures, though they warn it's not literal explosions, even if some dramatic headlines make it sound that way. Still, with emergency officials trying to understand the danger, one urgent question is spreading fast. Could these cracking sounds and shifting ground be a warning sign of something much bigger coming? Or is this part of a natural process that will reshape the Pacific Northwest without causing a full disaster? What people can actually see, cracks in fields, damaged roads, and ground movement, is only a small clue to the complicated forces working below. Offshore, the ocean floor is being mapped more closely than ever, and the results are surprising. New features are showing up, including subtle cracks and zones where seismic energy is being released. Seismic readings and sonar scans from research ships suggest patterns in the seabed are changing, and some of these changes may connect to shifting crust and even the growth of new fault structures. The size and speed of these changes have scientists urgently rechecking their models. The land continues to move. The ocean swells above a foundation that now looks more active and unpredictable than expected. As each day passes, cracks that once seemed small can widen, and the scientific uncertainty only grows deeper. So what is really driving this sudden change in Washington's crust? And if this keeps going, where could it lead? At first, the warnings were quiet. Scientists issued advisories that the Cascadia subduction zone could be due for a shift, and that the Juan de Fuca plate slowly pushing beneath North America carried risks we still don't fully understand. But almost nobody expected these forces to become so obvious in just a matter of days, or for the ground itself to show such clear signs of change. The first clues were small. About 3 months ago, distant seismographs detected faint tremors offshore. These were steady, low-level vibrations that experts recognized as possible deep crust movement. But on September 24, 2025, everything changed. Seismic networks recorded signals with a level of clarity never seen before, suggesting the subduction zone was actively fracturing or breaking under extreme tectonic pressure. High-resolution instruments captured energy patterns normally linked to rupture, not just the slow sliding motion usually recorded, but sharp uneven movement that matched the formation of deep, unknown cracks along major parts of the plate boundary. Almost at the same time, Satellite images revealed new fissures on remote ridges in Washington. Hikers reported seeing ground splits that hadn't existed the day before. In some communities, residents described loud underground rumbling sounds, and geologists from the University of Washington quickly confirmed a major new fracture, one of several splits appearing rapidly across the region. And this wasn't only happening on land. On the restless ocean floor, researchers on vessels operated by NOAA documented a chain of seismic bursts, energy releases far stronger than normal background activity. Sonar scans showed changed seafloor terrain, including signs of seafloor fissures and clouds of sediment stirred up by movement below the surface. Within days, reports of shaking and vibrations spread inland. Neighborhoods trembled. Some roads developed shallow cracks, and the Pacific Northwest Seismic Network worked non-stop to track what was happening in real time. What they found was shocking. Crustal changes weren't happening only in small areas. They were happening at a speed that suggested something bigger and faster than anything previously recognized in this region. With the public growing more worried, one question stayed at the center of everything. Is this the start of a major disaster? Or could the land eventually stabilize after this intense tectonic adjustment? Scientists are on high alert, sending out urgent, crystal-clear warnings as the U.S. West Coast moves into a new era filled with shock, fear, and fast-growing danger. Just moments ago, the Pacific Ocean showed its most frightening side. Massive waves, bigger than anything seen in recent years, are slamming into the shores of California, Oregon, and Washington. Emergency sirens scream through the thick early morning fog. Coastal neighborhoods don't wake up to calm ocean sounds anymore. They wake up to the deep, violent crash of water hitting land, breaking windows, shaking houses, and throwing debris far inland. Lifeguard towers are being overwhelmed. Roads are disappearing underwater. Seawalls that were built to survive older storms are now bending and breaking under wave heights never expected. This is not normal seasonal rough water. This is not just another winter storm. This is a disaster unfolding in real time, powered by a rare mix of strong weather systems and ocean forces, with a level of unpredictability that even experienced ocean scientists are struggling to understand. In coastal towns from Newport Beach to ocean shores, fear spreads quickly as emergency alerts keep coming. Evacuation orders grow wider, and the ocean pushes farther inland, swallowing areas people believed were safe. The urgency is impossible to ignore. Scientists gather in emergency meetings. Data systems struggle under non-stop real-time readings. Local leaders admit they don't know what will fail next as infrastructure starts breaking down. And it's not only the size of the waves that is shocking, it's how suddenly they hit. Residents describe hearing a sound like distant thunder, then a loud explosion. Homes shake as water slams into dirt, concrete, and everything humans have built. Highways that carried traffic just minutes earlier vanish under violent foam. Streets turn into rivers. Power flickers, then dies as salt water shorts out transformers, leaving whole neighborhoods in darkness. But this is only the beginning. This is just the surface of something bigger and more dangerous. The giant waves are terrifying, but what's happening underneath is what truly worries scientists. It forces us to ask, what unstoppable forces have come together? And how much can the West Coast handle when the ground beneath it feels less stable every day? The visible destruction is only the first battle line. Behind these massive waves, long-building hidden problems are turning this event into something historic. Every time an enormous wave hits, it weakens cliffs, eats away at the base of seawalls, and tears down a shoreline that has already been slowly shrinking year after year. Emergency teams are rescuing families as non-stop water breaks apart roads, floods neighborhoods that were never marked on flood maps, and speeds up landslides along fragile coastal bluffs. For the people living through it, the change feels instant. One moment the beach looks calm, then suddenly a roaring wall of water charges forward without mercy. For ocean scientists and geologists like Dr. Yang Ma and Dr. Lena Chong, the biggest fear isn't just the violence happening right now. It's how every new surge makes the region weaker, pushing communities past the safety limits that decades of planning and engineering were built around. This isn't just a rare event. Dr. Ma calls it a reset event, a moment so severe it could change what we believe is even possible. And when the tide finally pulls back, what will be left behind? The damage on the surface will be obvious, but the more dangerous threats may be hidden. Cracks growing under highways, unstable ground, shifting river mouths, and tide cycles that no longer behave the way they used to. These signs point to an aftermath that could be far worse than flooded streets and broken buildings. Communities are now being forced to accept that this is no longer about what might happen. It's about what is happening right now. Scientists are urgently asking, can the old prediction models even measure changes this extreme? If this is the beginning of a new Pacific reality, what rare forces, what strange atmospheric patterns could create chaos this fast and this powerful? And how do we adapt when old assumptions collapse in front of a rising tide? Pause here. Subscribe to stay updated with expert insight and critical West Coast reporting as this extreme situation keeps developing. Get alerts straight from the scene. Everything is moving so fast that eyewitnesses can barely tell the difference between normal ocean danger and pure terror. Lifeguard radios explode with code red warnings. Rogue waves, huge, unpredictable, and powerful, rise out of nowhere, spilling over harbor walls, swallowing wide stretches of beach, and throwing heavy driftwood into parking lots packed with families trying to escape. In Santa Cruz, webcams meant for surf tourism capture something else entirely, a sudden attack. A wave hits so hard that railings snap loose and the boardwalk twists and splinters under energy measured in tons per second. In Newport Beach, the road beside the sand disappears under a rushing flood of foam. Surfers who normally handle winter storms rush out mid-session, paddling toward shore as escape routes begin to close and sirens scream. Coast Guard crews, usually running normal schedules, are now making repeated trips into dangerous surf. They rescue stranded drivers as water climbs up to car doors and spills across hoods. Within minutes, neighborhoods that have never evacuated before are racing uphill, holding pets and phones, staring at an ocean that has turned from a playground into a predator. The intensity is impossible to miss. You can see it and you can feel it. The air vibrates as waves crash farther and farther inland. Residents describe a deep rumble, the ground shaking with every new surge. This isn't coming from one isolated storm. Sensors along the coastline confirm it. At Scripps Pier, buoys built for worst-case situations are recording wave heights well above 50 feet. Data spikes from Arcata to the Balboa Peninsula. And every instrument confirms what emergency managers are now calling no place is untouched. From San Diego marinas to the protected harbors of the San Juan Islands, the same pattern repeats. What we once believed was strong and permanent now gives way in minutes. So what turns an ordinary wave into a monster? According to Dr. Yang Ma, it's not just wind or tides. It's a rare stacking of conditions. Storm energy travels across the wide Pacific, then gets boosted by unusual atmospheric patterns that increase both speed and height. When that energy hits the coast's complicated underwater shape, canyons, steep shelves, and uneven beaches, the waves break with devastating force. For scientists, the fear isn't only the size. It's how rarely these factors line up, and how powerful the result becomes when they do. Dr. Ma warns, we are no longer dealing with theoretical maximums. We are in territory we've never mapped. Recent emergency bulletins are blunt because there are few past events to compare this to. As Dr. Chang says, we're seeing events our models never truly predicted. The coastline is being reset physically and mentally right in front of us. So as old certainty falls apart, can science adjust fast enough to the new reality being revealed? Searching for answers, researchers dive into chaos math, atmospheric analysis, and marine physics. The traditional wave formulas, based on wind speed, storm distance, and wave period, now seem too limited. Every piece of the equation is being pushed beyond what anyone has experienced before. Dr. Ma points to red warning screens streaming non-stop data, She explains that the mix of wind-driven seas, low-pressure storm systems, and unusually warm ocean temperatures is creating waves that smash historical records. This isn't guesswork, it's measured truth. In recent days, offshore sensors from San Francisco to Hanalei Bay recorded wave sets with less than 3 minutes between peaks, matching the worst disasters described in the last century. Satellite images show coastlines shoved inward, dunes erased, and river mouths forced open by surging water. Experts warn about compound hazard stacking. Long-period waves from distant storms combine with local wind-driven swells, layered on top of high tides, then intensified by warmer ocean water. Timing becomes everything. Dr. Chang watches hydrographic maps without looking away. Hazards that once felt separate are now feeding off each other in a dangerous loop. When wind, water, and land line up like this, prediction breaks down. There is no time to recover before the next surge arrives. The impact is immediate everywhere. At Half Moon Bay, rescue crews move through streets turned into streams, pulling people from homes, hospitals, and schools. In Oregon's Lincoln City, boardwalks snap apart. In Washington's Grays Harbor, seawater pressure reverses drainage systems, forcing brackish water up through city manholes like geysers. Never has prediction science felt so uncertain, or the cost of failure so deadly. But even while the crisis dominates headlines, scientists warn that the biggest danger isn't always visible in the moment. Under the pounding waves is a quieter threat that has been building for years. Subsidence, the slow sinking of the land itself. For decades, researchers like Dr. Ma have warned that hidden forces, groundwater pumping, tectonic movement, and slow geological shifts can lower land levels so gradually people don't notice. But each storm surge and rogue wave does more than flood streets. It strips away sediment, speeds up erosion, and removes the natural protective layers the coast depends on. Today's extreme waves expose weak points in places that were once considered stable. Within hours, water covers streets and structures that engineering plans said should be safe. In parts of San Francisco's Marina District and Orange County salt marshes, land is sinking by millimeters per year, almost invisible until disaster suddenly magnifies it. What we thought was high ground is no longer dependable, Dr. Ma says. Her team's instruments now connect record flooding with rising land subsidence. Real-time satellite images show flood zone lines creeping inland season after season. Areas once outside the 100-year flood zone are now threatened by a single high tide. Making things worse, heavy winter rain soaks the soil, and seawater pushes up rivers, blocking drainage and turning flooding into an inland danger too. Entire towns are now trapped between flooding from above and flooding from below. This threat doesn't care if you live in a city or the countryside, Dr. Chang warns. Every step the coastline moves back, it doesn't come back. What gets stripped away doesn't fully return, and the data proves it. With old defenses, higher seawalls, bigger pumps, and simple relocation plans, looking weaker by the day, one truth is clear. The ocean is changing faster than our protections can keep up. And as evidence grows and emergencies deepen, the questions become even more urgent. What happens next? Will this become normal? Can any defense survive repeated assaults like this? Scientists are not sugarcoating the answers. Dr. Marcus Ellery, a geologist with the California Department of Water Resources, speaks plainly. This isn't a single event. This is a compound hazard. Ocean waves mixed with soaked ground and record rainfall create threats you can't separate or control one by one. In past winters, hillsides collapsed after modest rain. Now, with repeated monster waves, high tides, and waterlogged soil, debris flows and landslides are happening in places no one expected. And the damage doesn't stop at the shoreline. It spreads inland. Above Santa Barbara, evacuation routes fill, not just with coastal residents escaping the waves, but with families from valley towns facing trapped rivers and failed drainage systems. Infrastructure everywhere is at risk. Schools close. Hospitals move patients. Shelters fill with people who don't know when or if they can return home. The emotional cost is heavy. People who have evacuated multiple times in just a few years describe storm fatigue, a growing exhaustion from repeated destruction and the constant breaking of normal life. Emergency managers like Lisa Mendoza, forced to send alerts over radio when digital systems fail, describe the growing struggle. People don't get the warnings, systems break, and there's no single point of failure. Just problem after problem stacking up wave after wave. Even power is no longer guaranteed. By late afternoon, hundreds of thousands of homes are